Good morning, everybody, and happy Thursday. Not a bad day in Calgary. The sun was out this morning, a little bit cloudy, but that snow is doing exactly what we wanted. It's getting into the ground. We're getting the moisture. If you've got some perennials or bulbs that were already breaking through, I'm not worried about them. I also have that. They should be fine. We got good snow coverage. Nothing should have been up enough that it broke. The only thing I would be concerned about really quickly are trees and shrubs. It was warm enough that the sap isn't frozen. So the reason trees and shrubs can handle that in the winter is because everything is frozen. So they're solid. They're really, really strong. Right now, it will have thawed, so they're more bendy. No leaves to stick to. So if it hits branches, they should be able to take the weight, or it should be bendy enough that the snow fell off. There might be some breakage. Prune accordingly. If it's a big branch and you're not sure, please get a professional. Don't risk hurting yourself. I'd rather see a dead branch last until you can get somebody than have somebody, leaning over with a chainsaw or a saw. If you don't know what you're doing when you're cutting a branch, it can kick back. So just be careful. But on the whole, what we got 2 days ago will be beneficial for us, not bad. I mean, speaking personally, it sucks. But speaking as a gardener and somebody who wants to see that moisture and understands the weather patterns, it's very beneficial. So, we have to kind of play it off. The weather's just going to keep getting better. So we're good. So today we're going to talk about photosynthesis. And the reason we're talking about that today is all week we talked about seeds. The week prior, we discussed the parts of a plant. And one of the parts was a leaf. And what they did, and we mentioned photosynthesis. And then 2 days ago and yesterday, when we talked about germination in that process, part of germination is the cotyledons. And the cotyledons are there to kickstart the photosynthesis cycle. So I broke it down, photosynthesis. And the reason I did that is primarily because I couldn't write it all on one line because my handwriting is atrocious. And then Brandy pointed out that breaking it down makes it easier for people to understand the pronunciation. So that's the one that we're going to go with. I did this deliberately. So photosynthesis. Very simply, it is a process that plants use, and there's a much longer definition, but we always condense the definitions here. Easy to understand definitions. Nobody's writing exams, so we keep it simple. It is a process that plants, everything behind me, everything you see around me here, go to convert light energy into chemical energy through the process of cellular respiration. So all that means is the cells are breathing and there is a chemical reaction, and light is one of the catalysts with that. So basically, in a nutshell, and we've talked about this, and I've got my handy little picture here, is what happens is the sunlight hits the leaf. And in the leaf, there are cells, just like on my skin, my hair. All living things are made up of cells. Some living things are just a cell. But all living things are constructed of cells. As we've talked about before, plant cells are very different from animal cells, like a kangaroo and a pansy, radically different. They're both living. They both respire. They both need energy. And what happens is in a plant cell, in the leaf, there's something called the chloroplast. And the chloroplast is the engine of photosynthesis. And what happens is our light around, the sun's peeking back through, good timing, Mr. Sun with his hat on. The light hits the leaf. The leaf absorbs that light, and it takes water that's come up from the roots. So there's our roots, and it's pushed water up into the cell here, and it takes that, and then it also takes the carbon dioxide. So as I'm talking, I'm emitting carbon dioxide. The plants are using that. And as long as there's light, artificial grow light, sunlight. As long as there is light, photosynthesis is happening. And what it does is it takes the light, it takes the water, and it takes the carbon dioxide, and the chloroplast now takes that energy and it turns it into a chemical, and what it gives out is fresh oxygen, right? Carbon dioxide, ooh, it's black. Oxygen, nice and pink. I didn't have another color for oxygen. Yeah. I couldn't have exactly done it white. Maybe blue, but blue is my root color. So I was limited, and it was the first one I grabbed. It puts out oxygen. I'll get back on track now. But more importantly, it puts out sugar. And the sugar goes back into the plant. It is the food source. It is the building block. It's the energy. Now, in an ideal location, this plant here, it's had everything it needs. It's warm. It's not damaged. There's no disease or bug eating it. So this plant right now is putting all that sugar into the roots. Oh, by the way, Throwback Thursday apron. Oh, yeah. Wow, I did, and digress, get back on target, immediately digress again. This used to be our old logo. This used to be our old color. We found one, so we're going to wear this on Thursdays. Now, if a plant is damaged, an animal has chewed it, there's a bug, powdery mildew, something like that, the plant is going to use that energy to fight that, much like we do. If we're injured, if we're sick, eat very good foods, eat healthy, lots of fluids, and that's what the plant is doing. So, when we're sick, orange juice, always a popular one to go to. Orange juice has a lot of sugars in it. Our body can break those down quickly so it can start feeding what we need to combat the sickness. Plants are no different. It's a very, very same process that it uses. Then the other thing it uses the sugar for is production, growth. So when it puts out flowers and seeds, that requires a lot of energy from the plant. And again, that energy comes from photosynthesis. And something really, really, really cool, I think anyway, is that life, as it has evolved on this planet, without photosynthesis, without this process, plants wouldn't live. Without plants, there wouldn't be life on this planet. Everything at the end of the day is reduced to plants. So the food we eat, the air we breathe, everything like that, all happens because of this amazing, amazing process. And it's happening right now. This plant, I'm just going to keep this one. I keep pointing to this one because it's so big and it's right next to me. Yeah, but this one's so much easier to manipulate. Right now, that chemical process is happening. It is firing. All of those cells are going, but we can't see it. We are never aware of it. We may notice after a week, after 2 weeks, oh, my plant's in bloom. Oh, look at the new growth. That's how we notice it. But we can't see it happening. It's happening at a cellular level. And basically, at the same time that it's undergoing photosynthesis, its respiration is happening. So on every plant leaf, there are tiny, tiny little holes called stomata. Can you see them? No, you can't. Trick question for anybody who said, yeah, the singer, gotcha. And stomata they're tiny, tiny little holes, and it's part of the plant's respiration. So plants respire or breathe through their stems, through their leaves, through their roots. There is a gas exchange even at the root level. So if we have a leaf, going to draw my leaf, standard leaf, okay? And the stomata are tiny, tiny holes all over the leaf, okay? Now I'm doing them bigger here so we can see what we're talking about. But just to give you an idea of how many there are, in 1 square inch, so if you remember yesterday, I said I used my finger as a ruler. So that right there on a leaf, I would draw on the leaf, but people won't buy it. So I'll stick to this. I admit that would be cool though. In 1 square inch on a leaf, so on this leaf in 1 square inch, there are approximately, and all plants are different, air plants and cacti, succulents, oak trees, so they're all different. But on an average, in a square inch, there are 7,500 stomata. There is no way we're seeing that. We're just not. You can't even feel them. And their entire purpose is part of the respiratory cycle of the plant. So during the day, when photosynthesis is happening and that chloroplast is firing, the plant is pulling in carbon dioxide and pushing out oxygen. So what happens at night? Well, at night, there is no light. Without the light, the system of photosynthesis isn't happening. So here we have the light hitting the leaf. The chloroplast is taking that. The roots, because we all water our plants correctly all the time, has pulled moisture in, and then there's carbon dioxide in our air through us emitting it, etc., etc. And this happens, and the plant goes amazing, and it gets these sugars. But while it's doing that, the sugars are kind of inert. They just they go to where they're needed, where the plant is damaged, to the roots, to the seed pod, wherever. The plant divvies it up. Much like us, if we're running a race, our body decides where we need the energy. It goes, oh, we don't need this system right now, but we need this. I need to get oxygen down here, so our lungs are working harder. Our heart's going faster. Our digestion is probably diminished because we're not digesting food when we're running a race. It's not a good idea to anyway. So at night, suddenly we've lost the light. So now there's no light hitting the plant. There's darkness hitting the plant. I don't know how to draw that. Basically, is that. So purple is dark. But every living thing on this planet respires, it breathes. We may not recognize it, but there is a gas exchange of every living thing on the planet, and plants are no different. And there was an old wives' tale a long time ago that you shouldn't have plants in the bedroom because at night it's reversed. Plants intake oxygen and they push out carbon dioxide. However, it is absolutely not true. The minimal amount of carbon dioxide they push out is massively offset by the oxygen they put in. So to give you some perspective on that, in an average size bedroom, so like a 15 by 12 foot bedroom, if it was hermetically sealed for the night, which our rooms are not, but if it was, you would require around 6 million plants this size in order to start polluting the air. If you can fit 6 million plants in a room that size and then go to sleep in it, the ability to breathe is probably the least of your problems. So it is never, ever, ever enough. That is an old wives' tale, and it comes from that fact that these plants respire, but there is no light happening for it to undergo photosynthesis. So what it does instead is now it just breathes. It brings in the oxygen, and then the oxygen, which we draw in pink, as the plant brings it in, it becomes the catalyst to start breaking down the sugars. So all of the sugars that the plant has made, now the oxygen starts working with them, and the plant starts repairing itself, and it starts growing. And have you ever noticed during the day, lots of sun, you have your plants outside, nothing really happening. The plants are looking healthy and they're nice and green and they're vibrant, and we've watered them properly because we all water our plants properly always. And then the next day you wake up and there's flowers and you're like, oh my God, where did these come from? They're amazing. And you're so excited. It happens to me all the time because I check my plants way too frequently. That happened because during the night, the plant was able to break down the sugars. Then it sent the sugars and said, open up the flowers, open up the flowers. I have the energy now. It opened them up. During the day, it pulls in more light, has everything else it needs, and boom, photosynthesis happens and we start getting sugar. So you've heard me talk about photosynthesis a heck of a lot, and that's how it happens. And in germination, those cotyledons that emerge, their entire purpose is to start that cycle. The seed has enough food to be like, bam, cotyledons, the cotyledons get light, and away we go, and that's how we get a mature plant. So that's photosynthesis in a seed coat. I'm not going to use nutshell anymore. Tomorrow, Hawaiian Shirt Friday, best day of the week. One, it's Friday. Two, I get to wear Hawaiian shirts, which I technically could wear any day, but I've arbitrarily decided that it's Friday. Stay warm, everybody. Stay safe. Enjoy your day, and we'll see everybody tomorrow for some Q&A. You have any questions, send them in. We'll even talk about the weather in a little bit more detail, okay? Take care, everybody. See you tomorrow. Come visit us at the car if you get a chance. Bye now.